Good afternoon, everyone. My name is Michael Pinar, and this is my Module 1 submission for CSE 310. I built a fully stacked project management application called PROJECT. It uses native Node.js for the backend server and SQLite for the relation database with raw SQL queries and pure vanilla JavaScript for the front end. It has no frameworks whatsoever. And now I would like to show you all the app running. So here the app is running. You can see the dashboard as it is. How can I say it shows live stats here? Dashboard is showing live stats. And then the drop down here is populated dynamically. When the page loaded, JavaScript made a fetch request to my API projects endpoint, which ran a select query on the SQLite database and returned these project names as JSON. So now what I'll do is I'll add a new task. And I'll just call that in progress just to see that everything is functional. So nothing is just designed. Everything is functional. I can add. You can clearly see here now this has been added and the status as it shows in progress. And then if I press delete, you can also see that it is, how can I say, that the delete action button is also functional. And not just that, let me also show you that if I add a task, you can see here total tasks also changed. And then in progress, it shows there now how many tasks is in progress. And if I delete, you can see that data is completely changed. So now I want to come over here to the file structure, and everything in the public file is the front end development. And then when I come here to the server.js, this is the complete back end. So when it comes to the back end, the server starts here. So when we look here, we can see connected to SQLite database. So I open the SQLite file using nodes built in node.sqlite module. Then I run two create table statements. And then if you notice, the task table has a foreign key pointing to projects.id with on the lead cascade. This is the one-to-many relationship. One project can have many tasks. I'd like to scroll down to this function called create app server, and we can see the HTTP server is created with htt.createServer. So instead of express routing, I use simple if-else chain matching the HTTP API/projects route. It runs a prepared statement and sends the rows back as JSON. For post request, the body arrives as a stream of chunks over the network. And if I scroll down, and when it comes to the post route, I have a function that listens for data events, collects the buffer chunks, and resolves the promise when the end event fires. Then I phrase the JSON and run a parameterized insert. Let me quickly go to that, as you can see here. And the question marks are placeholders. The values are bound separately, which prevents SQL injection. And when I scroll down to the delete route, For the lead, I phrase the task ID out of the URL string by splitting on and grabbing index 3. So if we come here to isNAS, I check with isNAS to guard against bad input, then run the lead query. And then when I check for results, if it's 0, no rows were deleted, so I return a 404 statement, meaning obviously not found. Now when we go now to the front end, so on the front end, init calls promise.all with two fetch functions running simultaneously, one for projects, one for task. This fires both HTTP requests in parallel instead of sequentially, cutting startup latency in half. So when we look at this function, when tasks arrive, I clear the T-body with inner HTML and rebuild every row from scratch. This is called DOM reconciliation. A full redraw on each mutation. So when I come down here, and if we look here, the document fragment, I use the document fragment to batch all the row insertions into a single DOM operation, avoiding a layout reflow for each row. So for the lead buttons, I use event delegation. So for the lead buttons, I use event delegation. So instead of attaching a click listener to every single button, which would get wiped on each redraw, I attach one listener. Clicks bubble up to it, and I use event.target.closet here to identify which button was clicked. This means listeners work for any row, even newly added ones. And now when it comes to the SQL concepts, to summarize it, I have one-to-many relations. I have a one-to-many relationship enforced by a foreign key. I use inner join to merge tasks with their project names in a single query. All write operations use prevent SQL injection. The database is sealed automatically on first run if the tables are empty. And on the lead cascade means I never have orphan task if a project is deleted. So this covers the full stack, a native HTTP server,